a blank unit circle. Okay, I suggest that you never memorize the unit circle. Okay, I'm going to write that right here as a rule. Do not memorize this. Okay, when you're solving problems involving trig ratios with special triangles, if you have to keep looking at the unit circle, what that should be an indicator of is that you don't understand it. Okay, you don't need to look at this circle pretty much ever, but you need to know how it works. You need to know what it's comprised of. That's the most important thing. And basically, in a nutshell, what this is this entire circle is made up of two triangles. Okay, I'm going to draw them right here. They're the special triangles, they call them. Okay, this is the 30, 60, 90 triangle. Okay, the 30, 60, 90, they have these side lengths. It's just root 3 over 2. This is be 1/2, and this will be 1. This right here, this hypotenuse of this right triangle, will be the same as the radius of this circle. In other words, I could draw it like this if you like, going on this way. Oops. And I could draw it straight down and put a right angle there. Okay, that's how that works. So this is the 30, the 60, and the 90 triangle. It's the same thing going on here. So like I say, this is root 3 over 2. This side would be 1/2, and this would be 1. This hypotenuse is the same as the radius of the circle, and it's 1. Okay, 1 unit. Whatever we want to call these lengths, we could call them centimeters, meters, inches, doesn't matter, but this is the length of 1 unit. That's why it's called a unit circle, because the radius is 1 unit. Okay, the other triangle that we need to worry about is the 45, 45, 90 right triangle, which is an isosceles right triangle. So these sides are the same, but so are these angles. This is 45, this is 45, and this is 90. So these side lengths, if this radius is 1, this hypotenuse is 1, then we'll call it root 2 over 2. And this one also root 2 over 2. These two triangles you should memorize. Okay, memorize the two special triangles, but please do not memorize the unit circle. That's a lot of extraneous information that you don't really need to do. Okay, but let's go ahead and fill out this unit circle. That's what this video is about. And so you can kind of see some patterns in the unit circle. That's how I like to fill it out, as I recognize the patterns. Once you kind of understand how it works, then you can basically imagine what the unit circle looks like in your head, and you can solve any trig ratio problem as long as it's comprised of a 30, 60, 90 or a 45, 45, 90 triangle. Okay, so that's pretty much how that works. So let's go ahead and fill out this circle. Let me show you the easiest way I can think of to do it. But please do not memorize every coordinate and every angle inside this thing. Okay, all right, so let's go through this. Let's change my pen to something here. All right, the first thing I'm going to go through is the angles. Okay, we start off, we call this right here the center. We call this the origin. Okay, we can give this the coordinate 0, 0. So it's like looking at a Cartesian coordinate system. This is the origin. So this is the x-axis right here, and this up here is the y-axis. Okay, this line right here. So what we're going to do is basically we're going to start measuring all of our angles. We have two sides, two rays, and this is the vertex that connects them. And the initial side is always this positive x-axis. So we measure all angles from the positive x-axis, and they go somewhere else, which they call the terminal side. So if we start here, we'll say this is 0 degrees. Okay, and we're going to move up. Okay, so there's 360 degrees in a triangle. So here's 0 degrees, and this will be 30 degrees. And then it goes 45, and then we go to 60, and then 90 up here. So if you see this pattern, we go up 30, and then we go up 15, 15 more, and then 30 again. So it goes 30, 15, 15, 30. So let's go 30 past 90, so that's 120. Then we'll go 15 beyond that, which is 135, 15 beyond that, which is 150, and then we'll go 30 more, which is 180. That is a half circle. Okay, it's half of 360. So we'll go 30 more. Okay, that's going to be 210. Then we go 15, which is 225, and then we go 15 more, which is 240, and then we go 30 more, which is now 270. That's 3/4 of a circle. Now we go 30 further, which is 300 degrees, 15 further, 315, then we go 15 more, which is 330, and then we go at last 30 more than that, which is now 360. So we could call this angle either 360 degrees or 0 degrees. Technically, it's the same terminating side. Because they terminate in the same spot, 360 and 0 degrees are both called, they're called coterminal angles because they'll end in the same spot. Okay. So the next thing we need to do is the radians. Okay, let's do the radians in green, I suspect. Okay. All right. So the first thing we'll say is I'll say 0 radians and keep this consistent. Okay, so we have 0 radians, and we're going to go up. 30 degrees is the same thing as pi over 6 radians. This is what we're going to do. We're going to look at the patterns. We're going to exploit the patterns in the unit circle. So just follow along. Everything is going to come into place. So from 0, we go 6. Then we'll write 4, and then 3, and then 2. So from the x-axis, you go 6, 4, 3, 2 on every side. Okay. So here we'll go 6, 4, 3, and then back up to 2. On this side, we'll go 6, 4, 3, down to 2. From here, the x-axis, we'll go 6, 4, 3, and then back at 2. Okay, in this first quadrant here, we're going to just put pi above everything. Pi, pi, pi. And even up here at 90, pi. So it's true to say that 30 degrees is pi over 6 in radians. 45 degrees is pi over 4. And 60 degrees is pi over 3. 90 degrees is pi over 2. Very straightforward. In this quadrant, we're going to subtract 1 from the bottom. So if I say 1 less than 6, we'll call that 5, and then we'll put the pi. So this is 5 pi over 6. This one will be 3 pi over 4. Subtract 1 from the bottom. This will be 2 pi over 3. Okay. We should know that the entire circle, 360 degrees, is the same thing as 2 pi radians. Okay, that's a full circle. So half of that, of course, would just be pi radians, which is what 180 is. Okay, so that's pretty straightforward for the x-axis coordinates. Right here, in this particular quadrant, we're up here. We took 1 off the bottom. Now we're going to add 1. So 1 more than 6 will be 7 pi over 6. Add 1 to the 4 here. This would be 5 pi over 4. Add 1 to the 3 here. This is 4 pi over 3. And then add 1 to the 2 here. This will be 3 pi over 2. Okay. In this particular quadrant, this is kind of tricky here. We're actually going to double the bottom and then subtract 1 from that. So if I double 3, I'll get 6. Take 1 off of that, and it's now 5 pi over 3. Double this one, you'll get 8. Take 1 off. 7 pi over 4. Double 6, you get 12. And then 1 less than that is 11 pi over 6. So that's how you do the radians for the entire unit circle. Just know the patterns. Okay. So now we have to get to the tricky part, which is the coordinates. Okay. So I'm thinking what I'm asking you for this coordinate is right here on the outside of the circle. What is this coordinate here? If this coordinate right here is 0, 0, what is this coordinate here? Keep in mind that this radius right here, this entire radius, I told you is what? 1 unit right here. Okay, just 1 unit. So if that's true, then this coordinate right here on the x-axis will be the coordinate 1, 0. Okay, because we go 1 unit in the x direction, and we're not going up or down, so y is not changing. It's still 0. All right. So we're just going to follow this. Remember, we're going to use our special triangles. This is 30 degrees. So here's 30 degrees right here, which means my x-coordinate is √3 over 2, and my y-coordinate is 1/2. So I say, okay, we're going to say √3 over 2 is the x-coordinate, √3 over 2, and this is 1/2. Okay? We're going to get to the 45-degree angle, which means these x and y coordinates are the same. This is √2 over 2 and √2 over 2. So we're just going to write that in there. √2 over 2, √2 over 2. And then we get to 60, which is the same thing as this triangle, except we're going to flip these two sides. Okay, we're just going to flip these. So we're going to take this coordinate and this coordinate right here, and we're just going to switch them, because we're switching the angle and the triangle. So we're just doing a little switch. Okay, so that's 1/2 and √3 over 2. Right up here, we're just going to go up by 1 in the y direction and nowhere on the x. So it's going to be 0, 1. Okay, and that's how that's going. So it kind of works this way, and we're just going to kind of copy these coordinates in all the quadrants. Keep in mind that in specific quadrants, x is positive and negative, and so is y. So if I move this coordinate over here, we'll keep them the same. Root 3 over 2, 1/2. These are like a mirror image, except we know in this particular quadrant, if this is the point, the x value should be negative. Okay, in the second quadrant, the x value is negative. So we're just going to copy all these coordinates and then make sure that the x values are negative. So this is going to be negative root 2 over 2. The y will stay positive, root 2 over 2. Here we'll just copy this one over here. So this will be negative 1/2, and this will be positive root 3 over 2. And now we have these coordinates. If this coordinate is 1, 0, if we go in the other direction for x, this one will be negative 1, 0. Very straightforward. Okay, same stuff. We're just going to copy these down here like we're just doing a reflection here. But remember, in this quadrant, both x and y are negative, both of them. So we're going to say here is negative root 3 over 2 and negative 1/2. This will be negative root 2 over 2 and negative root 2 over 2. And this will be negative. We're going to switch these right here, negative 1/2 and negative root 3 over 2. Okay, it's like basically copying what's up here to the bottom, reflecting it across the x-axis and making sure that the coordinates are both negative. We'll do the same thing on this side. We're going to reflect this way, but in this case, only the y will be negative. So this will be root 3 over 2 and negative 1/2. This will be root 2 over 2 and negative root 2 over 2. And this one will be this is going to be 1/2, positive 1/2, and negative root 3 over 2. Again, we're going down in this direction by 1, so on the y, so it's going to be 0, negative 1. So we've actually completed the unit circle. It's fully labeled. But now let's do a quick explanation as to what we just found. Because why do we do all this mess, right? What is the point in this? Well, the point really is what I should be realizing is that this is a right triangle. Okay, that was the idea. That's why we're doing this. This is a right triangle. And I now know that this side is a half because it says this y value is a half. I also know this side here is root 3 over 2 because I said so right here. This central angle right here that I'm creating, this particular angle is 30 degrees. Okay? And what I'm going to say, because I know that this side right here is the side opposite this angle, that this is the opposite, this is the adjacent side, and this is the hypotenuse. We know that the cosine is the adjacent over the hypotenuse, but the hypotenuse in every triangle, the unit circle, is always 1. It's always 1 unit. It's done that way on purpose. Okay? So if I say this over this is the cosine of 30, which is true, dividing by 1 doesn't do anything. So we never have to worry about the hypotenuse. It's always 1. So basically the adjacent side is the cosine of 30 degrees. So what I mean by this is that the cosine of 30 degrees is in fact root 3 over 2. Just this x value. So this is the cosine. Always, all these x values are cosines of these respective angles. And then for the sine, it's the opposite over the hypotenuse. Again, the hypotenuse is 1, and dividing by 1 is pointless. So we'll say sine of 30 will be simply the y value right here. The sine of this angle is the y value, which is 1/2. So basically, the unit circle will tell us all the sines and cosines of every one of these angles, because we just look at the x values and the y values respectively. Okay, the cosine and the sine. So that's it. Okay. And I don't want you to ever memorize this, okay? If I give you a specific angle, okay, let's say, for example, I give you 7 pi over 6 right here, and I ask you for the cosine of that, do not memorize the unit circle. Just remember, in your head, you know that this is pi, radians, and this is 0, and also 2 pi. Okay, if I ask you for 7 pi over 6, remember that a half circle is pi radians, which is the same thing as what? 6 pi over 6, because what happens to the 6's? They would cancel. Well, I'm not asking you for 6 pi over 6, I'm asking you for this one, 7 pi over 6, which you know you have to go a little further. Okay, you went 6 in this direction, we have to go one more to get to the what? To the 7. So this entire angle here is 7 pi over 6 if I measure this whole thing. But the great thing about this is that you have now what is called a reference angle right here. because now you can create a right triangle that's upside down. Okay, and it's one of these two special triangles. In fact, it's this one right here, 30, 60, 90. We know that we had to go how far beyond 6 pi over 6 to get to 7 pi over 6? This angle right here is pi over 6. And pi over 6, of course, is the same thing as 30 degrees. So this angle is also 30 degrees right here. That's what I'm telling you. Which means this angle is what? This angle has to be 60 degrees. We now know the ratios of the 30, 60, 90 triangle because you should have memorized those, just the triangles. Okay? So that's what I'm talking about. If you know that, we'll change the pen here. I'm running out of colors. Let's go with red. So I know the side length here and this side length here because this is the 90 and the 60. I just remember this triangle. Here's the 90 and the 60, so that side length has to be a half. Of course, here it's what? It's negative. So negative 1/2. We're finding this coordinate right here. Okay, if this coordinate right here is 0, 0, this coordinate has a y value of negative 1/2 and an x value of negative √3 over 2. So now I can say definitively that the cosine of 7 pi over 6 is negative √3 over 2. If I go back to the unit circle, I can see that, of course, that was true. But I don't need to look at the circle to do this. So what you really just ought to do is make a specific diagram, singular diagram, for this particular triangle only, instead of drawing the whole thing, because a lot of it's extraneous. Okay, so that's how you should use the unit circle. That's how you fill it out. Recognize the patterns. Please do not memorize this. Okay, it's really not worth it. Understand the patterns, understand that it works, understand that it's simply made up of triangles. There's lots of triangles. Okay, we can keep drawing more and more, and they're just the two special triangles rewritten over and over again. Okay, all it is a bunch of triangles. So I hope that helps, and we'll keep practicing this, and I'm going to show you how to solve for any of these that I give you. If I give you any of these angles, you should be able to tell me all 6 trig functions for any of them. Okay, that's the point of this. That's what we're trying to do. But I appreciate you watching. Hope that's helpful, and good luck.